conductance of an n-channel MOSFET whose ID is equals to 10 microamps and VDS equals to 1 volt, VGS minus VT equals to 0.3 volts. Neglect the channel length modulation. Here we have to find out GM, which is dou ID by dou VDS, that is the drain conductance or drain conductance. This is drain as drain. So which is equals to, because ID is independent of VDS, so it is going to be a 0. That is option A is correct.
Losses of an electrical machine is represented in its equivalent circuit by. Now what is the no load equivalent circuit for any machine? We have resistance in series with inductance. Okay, this inductance is called as leakage inductance. This is because due to leakage fluxes. Okay, this is because due to core winding, or you can say winding resistance. Okay, at no load we have a fictitious resistance and inductance are connected in parallel. Okay, this is for any machine at the stator side. Okay, now at no load, let us take this is R0 and X0. The no load losses of an electrical machine is represented in its equivalent circuit by. Okay, this is the total no load current I0. It is divided into two parts. This is core component. Let us take working component, and this one is magnetizing component. You can write it as I mu. Now in the options he has given all in terms of resistances. Okay, you can also have an option like this. Okay, inductance and reactance are connected in parallel, or inductance and X0 is connected in inductance and resistance is connected in parallel. Okay, now here since all the options are in resistances, now what is this? This one is connected parallel to the stator side. So a parallel resistance which is having a high value. Okay, this value will be high at no load. So option C is the correct answer. Now output op-amp shown in figure is, okay, we have to find the gain. Okay, that is V0 by Vi ratio. Okay, since it is 0 volts, what is the virtual ground voltage at this point? Is also 0. Apply nodal analysis at this input side. Okay, so this is 0 minus Vi by, how many nodes are there? There are 2 nodes. Okay, this voltage we already know is virtual ground voltage of 0 volts. Let us take this node voltage as V. Okay, now write the nodal equations at the input side. So this is 0 minus Vi by R plus 0 minus V by R is equal to 0. From this I can say that Vi is equal to minus plus V. Okay, into minus 1. So this is Vi is equal to minus V. Okay, now what is the nodal equation at this node V? This is V minus 0 by R plus V by R plus V minus V0 by R is equal to 0. From this I can write it as V0 is equal to 3 times of V. So what is V? V is equal to minus times of Vi. So this is minus 3 times of Vi. So what is gain? V0 by Vi is equal to, gain is equal to minus 3. So that is option D is the correct answer. Minimum number of NOR gates used to implement XOR is. Since NOR and NAND are universal gates, you can implement using these gates to convert it to any other gate. Okay, that is XOR, XNOR, or you can say AND, or okay, anything else you can construct using universal gates called NOR and NAND. Now how many number of gates are required? If you see the construction of NOR and NAND, let us take this is a 2 input gate. Okay, first these two are given to a NOR gate. Okay, now this is the construction for NOR gates to convert into XOR gate. Okay, at this point of time you will get XNOR output, but what is the question? We require XOR. So at this point of time we will get XOR outputs. So how many are required? 1, 2, 3, 4 and 5. So option B is the correct answer. If the question is the minimum number of NOR gates used to implement XNOR, so what is the answer? Number of gates required is only 4. Similarly, The minimum number of NAND gates used to implement XOR is 4, whereas minimum number of NAND gates used to implement XNOR is 5. Okay. So option B is the correct answer.
Which of them are true? SRAM is used in cache memory. As it is true because SRAM is fast compared to the DRAM. And how do we design of a single SRAM cell consists of 6 transistors? It is true. And DRAM cell consists of 1 transistor and 1 capacitor. It is also true. In DRAM, the stored charge in the capacitor can be maintained only for short duration of time, because in DRAM the the data is stored in the form of voltages, because in the capacitor, which will lose its charge as a function of time. Hence we have to refresh it frequently. So all the statements are true. Hence option C is correct. 085 microprocessor carry flag is affected by the following instruction. There are 4 instructions are given as the options. Increment is nothing but adding 1 to the LSB, so it's not going to affect the carry flag at all. Complement accumulator is also not going to affect the carry flag, as well as ending is also not going to affect the carry flag, because ending is nothing but a logical operation, it's not an arithmetic operation. So subtraction is the only instruction which will affect the carry flag. So option D is correct. Is equals to x of n into x of n minus 2, then the system is here. This system is time invariant as well as a not linear. So and we have to check for the stability condition. So if x of n is finite, the y of n is also going to be a finite. Hence it is option B is correct.
Circuit test on a 3-phase induction motor is conducted at a rotor speed of. Okay, open circuit test on a 3-phase induction motor is conducted when the rotor should be blocked. Okay, the rotor should be blocked, but then this is the open circuit test in induction motor. How we can block the rotor? We can block by hand or by some external means connection. That means if you block the rotor, what is the speed of the rotor here? Speed is equal to 0. So NR should be equal to 0. That is option A is correct.